How to find the equation of a line. We defined and explained equation of a line in previous tutorials. However, here we will prove the accuracy of this equation using the gradient concept. Thus, given that any shift along the graph line brings a change in coordinates, which we denote as delta x and delta y respectively, we can write the final coordinates, x, y, of a point that starts moving from the point with coordinates and shifts by delta x and delta y along the line. We have the following shown on screen. We have the following shown on screen. We can express the equations. We have the following shown on screen. We have the following shown on screen. From the definition of the gradient m, we know that we have the following shown on screen. Hence we have the following shown on screen. Expanding the right side and collecting the like terms yields we have the following shown on screen. Expressing y0 minus mx0 by a single letter yields the simplified equation of a line. We have the following shown on screen. We have the following shown on screen. Since the constant n, we have the following shown on screen. We can find the formulas for the x and y intercepts by rearranging the above equation to isolate x0 and y0. This only requires us to consider the upper right part of the xy coordinate system. Thus, the x-intercept of a line for which the corresponding y-coordinate is 0 is, we have the following shown on screen. And the y-intercept of the same line for which the corresponding x-coordinate is 0, we have the following shown on screen. Example 1. A. Without plotting the graph, find the x and y intercepts of the line. We have the following shown on screen. B. Then, plot the graph to confirm the result. Solution 1. A. We have m equals 2 and n equals minus 5. Given the formulas for calculating the x and y intercepts of the line, we have the following shown on screen. We obtain after substituting the values. We have the following shown on screen. And we have the following shown on screen. This means the intercepts are at points P and Q, B. The graph of a line is obtained by connecting two known points of the graph and extending the straight line obtained beyond these 2 points. We can take two random values for the variable x, for example x equals 1 and x equals 4, and find the corresponding values by substituting them in the line's equation. Thus, for x equals 1, we have the following shown on screen. And for x equals 4, we have the following shown on screen. Therefore, the graph passes through the 2 points A and B. The graph is obtained by connecting these 2 points and extending the line beyond them, as shown in the figure. We have the following shown on screen. As you see, all the 4 points identified in belong to the line y equals 2x minus 5. This means the solution is correct. Remark: you don't need to remember the formulas for the x and y intercepts given above in theory. All you need to do is to substitute y equals 0 in the line's equation to find the y-intercept and x equals 0 to find the y-intercept. Let's explain this through an example. Example 2. A. Without plotting the graph, find the x and y intercepts of the line. We have the following shown on screen. with the x and y axes. B. Use the formulas of the intercepts to confirm the results obtained in A. C. Reconfirm the results obtained in A and B by plotting the graph of the given line. We have the following shown on screen. Solution 2. A. Taking x equals 0 in the original equation for calculating the y-intercept yields. We have the following shown on screen. Hence, the point P 0, 1 is the y-intercept of the given line. Likewise, taking y equals 0 in the original equation for calculating the x-intercept yields, we have the following shown on screen. Or we have the following shown on screen. Hence, the point Q 0.250 is the x-intercept of the given line. B. Since the line's equation, we have the following shown on screen. We have m equals -4 and n equals 1. From theory, we know that we have the following shown on screen. Substituting the known values therefore yields, we have the following shown on screen. Or we have the following shown on screen. And we have the following shown on screen. Since the intercepts have the coordinates p, 0, int, and q, int, 0, we again obtain the results obtained in A, i.e. p, 0, 1, and q, 0.250, for the intercepts of the given line with the axes. C. Let's plot the graph by connecting 2 points of the graph and extending them beyond the ends of that segment. This is done by taking 2 random x coordinates and finding the corresponding y values. Thus, taking x equals -1 and x equals 1 yields for the corresponding y coordinates. We have the following shown on screen. And we have the following shown on screen. Hence, points A, -1, 5, and B, 1, -3, are points of the graph, so we can draw the graph's line based on these 2 points as shown in the figure. We have the following shown on screen. That is all for lesson 14.3.2. To continue this tutorial, please watch 14.3.3, finding the equation of a line that passes through 2 known points. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.